Welcome again to Wickerson Studios. Might be the most boring video I've made, considering it's Datatrees in C#, kind of translated through Wickerson Studios, and I hope this comes in handy. My kids are making a lot of noise in the background, so that should be fairly exciting. Basically, as you know, I've been trying to find C script nodes that will help me build geometries, and I found this really nice example, and what I've done is here's the original, which comes out of Warsaw University of Technology, and that's open source, and you get that off of online, but it doesn't have a lot of stuff in it. Like, it just gives you things, and you're like, okay, what does that do? So I've gone through it with kind of a fine-tooth comb to make sense of it to me. What I've done is drawn up all the nodes under a section under data trees, which will allow me to find a series and range node, find a partition from input, partition from hard-coded, data tree information. Now, think of a data tree as an array of integers. That's really what I think of it as, and then how that's structured in a tree structure. Now, if you know how to look at the param viewer and switch it over to tree structure, that might make sense. And then there's also this preserving data tree structure, which is a method or something within the node itself. If you actually looked at right here, not under tree statistics, but I believe under tree branch, you have this chance within it to do this maintaining paths. So there's an interesting node in here that actually does it itself. So I brought that one in, which was preserving branching structure. And I also brought in the branch count and the number of indices, and I'll try and make sense of that as best I can without confusing you. And then adding one to each item is just a fun little script they use in here. I thought it was funny to make it into a node. So as we go into here, you'll see that this is actually probably should say start, stop, and step. And this is a series, and this is a range. Well, I didn't do that. I guess I could, but I've memorized it as that. What I did do is on each of these C scripts is I brought in the component.message framework and put in a message that says exactly what it is. So I don't depend upon bifocals. I can say whatever it wants. I don't have to group it, and that saves time. So let's just take a look at that script. And here it is. We'll just shrink it down. And what you'll see is with that little node right there, what is happening. I am basically building a function up here. The run script will basically run my component message to start with this message and range node, which I'm trying to do on every node. I'm creating a list for my series, and I'm setting that to the input XYZ, and I'm setting my list double for my range, which is creating a range XYZ. And then I'll output those as A and B. Now, what does the script look like? Here's what it looks like. It's written in a way so you have to think of it as a method. You don't have to think as hard up as a class or anything like that, but you can make a transition of thinking of functions into methods when you're dealing with C#. And you can see exactly what it's written as. There's one loop iteration here for the series, which will run through the start step. There's a bit of math in here you might want to memorize in these three steps under the double, num2, and item. That's not the one I recognize. It's the range one I recognize, which is this sense of going in here and using the number equaling the start. The number is then also, I like this little, well, it'll be less than or equal to start plus step, otherwise you'll have trouble with the for loop. Multiply it by the double, count minus 1, and then you have the number plus equals step. And so it's a nice condensed way of writing out what a range is. You can see it, you can cut and paste that and use it whatever you want to make a range. And if you're into series, well, you can cut and paste that and use that whenever you have to. But get in the habit of understanding the math and knowing how to script it. But if you had to cut and paste it, then that's fine as well. So my kids are making a ton of noise. So let's run that. And what we have is data that comes out. So you can see 3 different integer values of 0, 8, and 4 come out totally different for a series as they do for a range, which is a great way of understanding data and using it. But it does build a list. And you can tell by the smart wires that it is a list. So what I did was I merged it and I flattened it. So there it is, what it looks like as a merged flattened list, as opposed to not flattening it. Not flattening it's going to... Actually, why did I flatten it? Well, maybe they flattened it. Either way, that's what it looks like in its list state as they come together because I've merged them together. And then there's this little node here, which I think is funny to put in here. It's just a little script that will add digit 1 to each thing. And I guess you could kind of hard code in a variable here, an integer value like number here, and then bring it in as an input. And then you could change your list in any way you want by just adding 1 to it. So that's all it literally does. Take 0 makes it 1, 8 makes it 9. Yada, yada, yada. 6 makes it 7. So I just left that in there. I thought it'd be funny to throw it up there and use that periodically, like there be my special desperate need for a node to bump all my digits up 1. Here's getting into something more important. And they do a partition list. And the partition list they used was this one. I thought it was interesting. And they ran it. And I was like, well, why did they comment out all this stuff? Well, the reason they did that was so they could input a some list, and that's exactly what they do. They bring in some list, and they find the count to that, and then they run through with the data structure as partition list. The partition list, you're going to add some list, indices I, as it goes through that, basically to that new GH path I divided by count, and you're going to output partition list, and that's exactly what they do. And they end up with this data, and there it is partitioned. Well, I thought, well, what does that mean? So I went in there and I took the other script, and I thought, well, let's activate it. So I literally went in there, and let's pull that one back out. Here it is. And they've hard-coded what I call hard-coding, which is basically what it is. I'll just shrink it down a little bit. And I put it to my tree. I X'd out all this other stuff. They did leave this one, so I activated that one. My tree is basically a new tree, double. And then I added at all these points, what do these mean? Well, these are arrays, lists, arrays of numbers, and they will put things in. So if the path looks like 0, 1, 0, which I think that is the number of indices, 1, 2, 3, this one has 2, this one has 2, this one has 2, this one has 3, this is 2, this one has 1. You're going to put those into those categories, and you're going to list those indices counting at 0. So the first one's 1, so obviously I put 1 in somewhere, and there it is on 0, 1, and there's the 0, 1 path. And then the other path, 0, 1, 0, I use that twice, so it's going to bring in 3.14 and then 32. And that's basically what their hard code does, and that makes sense to me. And as I look at it as tree data, that makes total sense. Now, isn't it much nicer to deal with a single path with single list of indices, items at the end of it? Items, not indices, but items. And I always, sometimes when I'm talking, I confuse when I say indices and items, and I confuse a lot of people. But that's the list I'd like to deal with. But that's how complicated and weird you can make things. So this list is very nice to look at. No problem. But look at this wonky jive. When I do that, that's a wandering, wobbly little tree. But for people that like asymmetry and like to have a lot of power over their geometry and working within data trees, then do this. And then the output that's generated is really nice. It's this little script, and I call it branch count and number indices. And what you look at here is basically that's it. So it will run through in its first iteration. I'm going to pop that up here. It's going to run through this thing. Let's get rid of this one so we're not so dreadfully confused. And we'll shrink this one down a little bit. And I'll make it a little smaller so we can see what's happening there. Basically, it's running 2 for loops. And the first for loop is going to run through, as long as it's less than the branch count, X branch count, you're going to run through each item, and it's going to say exactly what it is. So it goes 1, 1, 0, 0, 3, 4, 3.14, 3.14. It does that, and it does it double for each one. And I haven't quite figured out why it does it double for each one, but I guess it does. Maybe because there's 2 branches. Maybe it would do more otherwise. But it's the bottom section I find interesting, because the next branch, the next section of what you're putting to output, and always use your output to kind of understand stuff, which is basically what I'm doing, but this is actually outputting this as A, the branch count. So it's done that. A is put out all this information, but the out is here, and that's how I kind of understand what's happening. A will look at. A is pretty simple. And maybe I'll bring that one over here, and that'll make it a little easier. So output is generating all of that in the first loop, giving me all that data, and it does it twice. But then it says the path number, the path 0, which if you take a look here, there's path 0, this section. It has 2 indices, and there they are, 1, 2. Actually, we're looking here. We're looking at these indices. Then it's saying here's path 1, and it has 3 indices, 1, 2, 3. So you're looking at the branches of the tree when you're thinking that and cycling out 1, 2, 3. So however you like to name those or understand those. And I think of them A, B, C. So this is A, this is B, this is C. And then the items at the end are listed. And there they are, 3.14 and 32. But this is just counting the indices, the number of rings, if you think about it. So this one's got 1, 2, 3. One of them has 1, 2, 3. The other one has 1, 2, 1, 2. And then the next one has 1. And they follow each other and they kind of overlap. And I like this green indication of overlapping. I believe that's what's happening there. But you have incredible control over running your data and understanding it on these different paths and having total control to get in here. And I was having trouble, with relative items and all the tools that were allowed within the sets and the tree functions. But now I can see it. I can literally see it written out. And then this is a nice little thing to process that and take a look at exactly that, not the partition list, that go in there exactly and take a look at your branch count and your number of indices, which is why I've hard-coded that or written that into the component message. And I hope that makes sense, because otherwise you're just dealing with some pretty simple stuff. And you can see here that you have your path 0. Where is it? Here we go. I've got path 2 branches, so I have path 0, which has 1 indices. And where was I seeing that before? Right here. You see this one being 0, it has 1 indices. And right here, one indices here, and it has those items on the end, which I've actually listed, which is this tag right here for A. It's going to tell me 5 and 4. The second one is one path has 1 indices. So that's really the data of what's being processed here down here. It's counting up 2, 3, 2, 2, and 1. So you're laying hold of that. Now it kind of wraps up with that. It says, okay, well, don't forget that those were the numbers that were coming through. That's what was being processed. That's interesting. It just jumped and did that to me. What did that just do to me? Hang on. What the heck? Oh, yeah, I jumped way over there. Okay, so basically that's the data that's being processed. That's what's being described. Then they go down to the final operation, which I think is a really nice node system, that they go in here and make sense of the tree statistics and the tree branch. So you can take the tree statistics, you can process it, but over here I never really understood why it had maintains paths and not. So they wrote into this script above the same function as what's happening in those tree branches, and let's see what's happening to that sum tree. So there's the tree of the 9 values. There's 5 and 0, and there's a path, and there's 4 in 1 path. Now, if I say maintain that, take a look what's happening here. Kind of interesting to look at. And what it's doing is this last little play of merging it is it's not letting the merge tool break it up if I say maintain preserving branch structure. And that's going to be a wonderful node to use again and again. Otherwise, I'm going to end up running data together, and that's going to keep me working on different branches and different paths, which is very exciting. So they do an addition one here, which is interesting to see how it processes 2 sets of information and just adds this one to that one, that one to that one. So add works that way, but merge works totally different. Merge, without the maintaining, you'll see what it does is it just writes this one down, whichever one I put in first. This one I put in first. This one I put in first. It's going to write down that whole list, and then it's going to not maintain the path structure and then write the other one afterwards. Adding does quite something different than a merge. I think they did a great example to use that. The other thing that I was playing with was going back in here and saying, okay, well, what's happening if I don't maintain paths? Well, really, it just drops that path back down to 0, as opposed to counting that as one in a separate path. So I thought that was pretty interesting in how that was working. So I'm going to maintain the paths, leave that at 1. But what I'm trying to do is leave this system and not be concerned with this and trying to go farther into nodes that can make sense of data trees for me, and I can actually start writing them and scripting them and thinking of them. Now look at that awful path. Look at that awful script. That's one I can't write on my own, and I thank the university. I mean, it's open source. You can have a look at it, but really go in there, customize it, make sense of it, play with it. Like I said, an array, I think they reversed it. Why did they reverse the indices? Array sort. I guess you could do that if you wanted to. So I can go in and sort my array. I wonder what that's going to do to my data. Let me just run that. What happened? I think it just sorted my data out, or at least I thought it did. Let me maintain my paths and see if that sorts the data. Let me see what that one did. Let me cut that one out again. I'm not seeing anything different. And I shouldn't be wasting my time on this because I didn't spend time thinking about it. But as I put it there, it just takes a little longer to process. I'll have to get in there and play with their script a little bit to find it out. But basically, you're putting out the even number of branches and the odd number of branches. And I guess that'll allow you to play off of the 0 and 1 path. And that's exactly what happened. So I hope that makes a little bit of sense. It certainly gets you understanding some of the trickiest nodes in Grasshopper and seeing how they're scripted as opposed to being left in the dark and not knowing and spending your time here in the help menu trying to read this stuff, which doesn't give you too much to start with, and trying to find a YouTube video. It's wonderful that you've got it actually broken down here and you can see how that's scripted and start to make make sense of these for, if, else if, and else statements and conditionals as to what's happening. And I did like there was a little Boolean toggle on that one, which is opposed to going in here and having to click there. So keep in mind that all those nodes were scripted in C#, so you should be able to understand them in C#. I did add this cool little function here, so I can bring that into, if you'll remember, I've been working off of, I think this is it, this kind of system of trying to find a very interesting template to build a playful way of making geometries. And I've gone in and started with numbers, gone to points, gone to curves, gone to surfaces, and left this iteration tool throughout the whole thing. But because I'm dealing in trees, now I can start customizing and adding a few of these playful data tree nodes whenever I start to see dash lines in a script. So for example, on this one, as soon as I move from lists over to these dash lines, I know at any point here, I could be starting to drop in partition the inputs from inputs, and take some of those lists and start to divide them up and have fun with them and see how they translate and change my geometry. So this is a very visual way, if you think of node scripting as being very visual versus scripting hard into a C node or into a Python node, this is a way for you to be playful and figure out what you want to do. So I'm just going to save that one there. I'm going to go back over to this one here. I haven't got this one up online to share, but if I did share anything, it would be the version that I'm playing with, and certainly giving credit to the places that are inspiring me. I'm watching people take this type of scripting in C# into Unity right now. It's happening. Unichiro Horikawa, and there's another one online that's doing it. And I'm like, I don't know if I'm going to go that front end and show people how playful it is. I'm stuck so far in the numbers and the data and being excited about things like this, my own ranges and series, and being able to script those and to see the effects of that on an infinite amount of varieties of sculptures or artworks. That's what I think I'm doing with Grasshopper and C# programming. So I hope you enjoyed it, Wickerson Studios. We're 16 minutes in. That was a long, dry one. Lots of sounds of the kids, dogs beside me. Have a great evening.